Go ahead and continue with our review of Chapter 9 or Topic 9. All right, so this is all about quadratics. So we'll go ahead and pick up where we left off. Okay, so this one says solve each equation by factoring. Okay, so we've done quite a bit of this. So this one in particular, 16, notice we only have two terms. But the good thing is both terms have an x in them. There's an x squared and there's an x. So what we can do is we can always factor out the smallest of the x's. So then we can say, all right, so if we factor out an x here, then we're going to have x squared divided by x is just x. And then minus 12x divided by x, the x is canceled, just leaves you the minus 12. And that equals 0. Okay, so then our two possible answers is if this guy's 0, the whole thing's 0, so x equals 0. And then x equals 12, because 12 minus 12 is 0. Okay, pretty easy. All right, so 17 is a little more complicated because we have the 2 in front of the x squared. So what that means for us is we're going to have one of these guys is going to be 2x, and one of these guys is going to be just x. Because when you multiply them back together, 2x times x gives you the 2x squared. All right, so then we have a negative sign here. So that means one's going to be plus and one's going to be minus. Now the question is, which one's going to be which? And then our possible candidates for the number part of this is either 1 times 15 or 3 times 5. And typically, as long as the middle number isn't like really huge, you're probably going to use the numbers that are closer together. Okay. So we'll work with the 3 and the 5. So remember, any number that goes on this side is going to get doubled because of this guy, right? And since the overall is negative, let's put the minus sign here. Okay. So then I'm thinking, let's try the 5 here, and then the 3 here, like that. Okay, so then to double check yourself, all you have to do is check those inside-outside terms and see if you end up getting this guy. Okay, so if we do the inside here, we've got 3x positive. To the outsides, I got 2 times minus 5, that's minus 10x. And then 3 minus 10 is negative 7x. So these guys match up. So we're good to go here. Okay, and then to solve it, this guy's easy. We just say x equals 5. Okay. This guy here, we want to know when he equals 0. So the hack for this one is switch the sign on this guy, so make him negative 3, and then divide by this guy. So minus 3 halves or minus 1.5. Okay. Questions on either of those? Okay, cool. Let's continue on. All right, so this one says find the coordinates of the vertex of the related function and then graph it. Okay. So we're going to try to factor first. All right. So we're going to have x and x. All right, so we have a plus sign here. That means we're going to have a choice. We either have two pluses, because a positive times a positive is positive, or we have two negatives, because a negative times a negative is also positive. That's determined by the middle guy. The middle guy's negative, so we're going to use two minuses. Okay. And then we can do our bit where we say, all right, we've got 20 here and minus 12 here. We've just determined both these guys are going to be negative, right? So we got 4 and 5, but they only add to 9. So that's probably not our guy. So I'm thinking 2 and 10. So 2 and 10. Okay, so that's that. All right, so we went ahead and factored. Now, when we solve this, we say, well, x equals 2 and x equals 10, right? Okay, so what that tells us is that x equals 2 and x equals 10. That's when our graph is going to hit the x-axis at those 2 points, okay? And then since this is a positive x squared, the graph's going to be a U-shape, right? It's not going to be upside down, it's going to be right side up. All right, so last thing we need to do is we need to figure out the vertex. Okay, a couple ways you can think about this. We can use that bit where we say, well, x equals minus b over 2a. So in this case, you have minus a minus 12, so that's going to be positive 12. And then over 2 times 1. So 12 divided by 2 is going to be 6. That's one way you could think about this. Another way you could think about this in order to get to that 6 is, remember these parabolas are very symmetrical. So if we cross the axis at 2 and at 10, then halfway in between is where the vertex is. That's our lowest point because these things are very symmetrical. So the point halfway between 2 and 10, we can figure out like this. You could say 2 plus 10, and then we average those two values divided by 2. And there again, we see 12 divided by 2, which is 6. Okay, so then the last thing we want to do to figure out the vertex is we're going to plug in 6 every place we see x. So let's do that over here. So we're going to have 6 squared, and then minus 12 times 6, and then plus 20. All right, so 6 times 6, that's 36. 12 times 6 is 72, so negative 72, and then plus 20. And again, use your calculator on those if you want. All right, so we'll go ahead and add these guys up. So I've got 36 minus 72, and then plus 20. So that's negative 16. So our vertex is going to be at 6, negative 16. Okay. Then it says graph it. Well, we're going to use Desmos as we normally do. So let's bring in our Desmos here. So let's do x. X. You could use the other format too. There's our guy. All right, so let's move him in that we can see a little bit. All right. So as predicted, we cross at 2, we cross at 10, and down here is 6, negative 16. And that's enough points to get your graph across. Okay, so we know we bottom out here at 6 minus 16. We come up here, we cross at 10, we cross at 2, and then we just keep on going. Okay, makes sense? All right, so let's get Desmos out of the way here. So Desmos exit stage left. Check out another one here. All right, so this one says factor, find the coordinates of the vertex. So this is the same kind of problem. Okay, So let's go ahead and do this one then. All right, so same thing, we're going to start off with factoring. So we just have x squared, so it's going to be an x and an x. So again, we have a positive there, but a negative here. So these are both going to be minuses. Okay. So this is an awful lot like the last problem, huh? So in this one, we will have 3 times 5, because 3 times 5 is 15, and 3 plus 5 is 8, and with the negative signs, it'll be negative 8. So we go 5 and 3. So then x is going to cross at 5, and x is going to cross at 3. Now if we use our hack that we had in the last one, then this is easy because the number that's halfway between 5 and 3 is 4. So for our vertex, we're going to say the first part of the vertex is going to be 4. And now we have to figure out the other part. So we plug in the number. So we say 4 squared minus 8 times 4, and then plus the 15. So 4 times 4, that's 16. So 8 times 4, that's minus 32. And then plus 15. All right, so let's add those guys up. So we're going to do clear it out. So 16 minus 32 plus 15. Did I do that right? No, that says 5. It didn't look right. Hang on. So 16 minus 32 plus 15. That's more like it, minus 1. Okay. So that's our guys. So this is our vertex here. All right, so let's bring in Desmos again. Okay, so this one is minus 3 and minus 5. So x minus 3 and x minus 5. Go. Let's make it a little bigger so we can see what's going on. So there we go. So as predicted, our vertex is at 4 minus 1. We cross at 5. We cross at 3. Perfect. Okay. All right, so let's move on. All right. Let's get Desmos out of here again. All right. Let's see what we got going on now. All right. So this says write an equivalent expression without a perfect square factor in the Radicand. So that means we're reducing the fraction. Okay. So what we need to do is we need to figure out the biggest square root that will go into this number. All right, so our first perfect square is 4, right? 2 times 2. So let's see if that works. So let's clear it out. So we're going to go 4, 20. And then we go divided by 4. Okay, so that works. But it's still a pretty big number, right? Let's see what else we can do here. What if we divide by 5? Because we know we can divide by 5, right? Let's see if that helps us. And that's 21. So you know what? 21 is 3 times 7. But those aren't perfect squares. 5 is not a perfect square. So it turns out, yeah, and we could do 10. 10 times 42. But I think the only thing we can do is the 4. Pretty sure. So then what we do is we say, okay, we'll do the square root of 4 times the square root of 105. And we didn't find any more perfect squares that go in the 105, did we? So that just means we're going to take the square root of 4 and make him 2 times the square root of 105. Okay? So that's all we got for that one. That's all right, Taylor. We're glad to have you. All right. So let's look at the next one then. So we got 84. So again, we know that we can divide by 4. So let's see what we get there. So if we do 84 divided by 4, well, it gives me 21, which we saw in the last one. 21 is 3 times 7. There's no perfect squares that go in there, right? So that means we could stop right there. So then we're going to do, so this will be 4, don't forget the 4 out front, times the square root of 4, and then times the square root of 21. And we know that the square root of 4 is just 2, so we got 4 times 2 times square root of 21. So we just multiply these two guys together, so you get 8 times the square root of 21. Beautiful. Yeah, I used to have a computer that was like that too, so I feel your pain. All right, so the next one, let's go ahead and multiply the stuff together. So if I multiply these guys together, 35 and 21, let's check him out. There's the 21 already, so 21 times 35. 735. All right, so 735. And then x times x is x squared. Now the square root of x squared is just going to be x, so that part's easy. So the question is there any perfect squares that will help us out here? All right, well, we know for a fact we can divide by 7, right? Because both these guys we can divide both of them by 7, right? So let's see if that's any help. So we go to our calculator, so 735 divided by 7. There's that 105 again, right? Now, can we divide by 7 again? Is the question. Let's try it. Divide by 7. Yeah. All right, so what that means is, check this out. If we do 49 times 15, we get our 735 back. Cool. So what we can do is we can say I've got the square root of 49, and then the square root of 15, and the square root of x squared. So the square root of 49 is just 7. The square root of x squared is just x. And then the square root of 15 we can't do anything with, so we leave that guy there. And that's it. Cool. All right. So for the last one, we'll try something a little bit different. We'll see if we can kind of work with the numbers ahead of time. So let's try that. So this is 32. I know I can divide 32 by 4, right? So what we can do there is we say, okay, 32. So 32 divided by 4 is 8, right? I can divide 8 by 4 again, can't I? So the thing you want to do most of the time is, if you can divide a number by 4, and it's kind of a big number, this one isn't super big, but kind of a big number, see if you can divide by 16, which in this case we could. So if we had 32 divided by 16, we'd get 2. So then this part is going to be square root of 32 is going to be 16 times the square root of square root of 16 times the square root of 2, which would just be 4 square root of 2. Okay? So I'm going to write this guy over here. Let's change colors so you can tell the difference here. All right, so. And this guy is going to be 4 times the square root of 2 x to the 5th. Okay, we'll come back to him in a little bit. So same thing with the 24. We know here we can divide by 4, right? So that's the square root of 4 times the square root of 6, and then we have the square root of x to the 7th. Okay. So square root of 4 is just 2, so this is going to be times 2, and then we've got the square root of 6x to the 7th. Okay. So we can multiply the 4 times the 2, so that's going to be 8. Right? And then we've got 2 times 6, that's going to be the square root of 12. And then we've got x to the 7 plus 5, so it's to the 12th power. Now remember with the x, it's just like a division thing. They don't put it there, but this is technically the square root. There'd be like the Radicand, as they call it there, would be 2. A cube root, it would be 3. For the square roots, they don't write it down for some reason. I don't know why. Okay. So what we can do is we say, okay, 2 goes into 12 6 times. So then we'd have 8 x to the 6th times the square root of 12. All right, we're getting close, but square root of 12 we can actually divide by 4, right? So the square root of 12, let's do a little side calculation here, equals square root of 4 times the square root of 3. Okay, and that's just 2 square root of 3. So now we've got 8x to the 6th times 2 square root of 3. So we're running out of space. We're going to take that up here to the top. Okay. So we just do this 8 times 2, that's going to be 16. And then we've got x to the 6th. That's all on the outside. The only thing left on the inside is the square root of 3. So some people like to do it that way. It's a little more steps, but it's a little smaller numbers to work with. Because if you multiply 32 and 24, you get a pretty big number, and then you have to kind of chip away at that. Okay. Questions? All right. So it says compare each one of these guys. All right. So I think we did one with the square root of 84 already. So that is the square root of 4 times the square root of 21. And then we've got x to the 5th. Okay. So we know the square root of 4 is just 2. Right? And we've got the square root of 21. Now let's talk about this x to the 5th. We say, well, 2 goes into 5 2 times. So that means you bring out an x. And however many times it goes in there is the exponent. Now we have a remainder, don't we? So we have 1x that's going to stay underneath the square root sign. So it turns out these guys are equal. Okay? And let's check out the next one. All right, so they want to compare these two guys. So your hack on this one is, since this is a 3, and they pulled that out front probably, then 3 times 3 is 9. So let's see if 135 can be divided by 9. So clear it out. We get 135 divided by 9 equals 15. Okay? So then for this guy here, you're going to have square root of 9 times the square root of 15. Then we have the square root of x to the 4th and y to the 3rd. All right, so again, 2 goes into 4 2 times. So we're going to have 3. We're going to have the square root of 15 under here, right? So the square root of x to the 4th is x to the 2nd, so he comes out front. And then with the 3 here, 2 goes into 3 one time, so you bring a y out front, y to the first, and you have a remainder, so he stays there. So these guys are not the same, are they? Yeah, it gets a little confusing, but like I said, we'll go over some of this stuff later. All right, ladies. Well, I got good news for you. I have to get to a meeting, so we're going to stop here for today.